Hello world and welcome to another video. Come for your education, but please stay for the motivation. Today's video is a continuation of our series on cracking the coding interview, and today we're solving a problem called intersection of lists. Feel free to pause the video to read through what the problem is asking for, but I find the examples more descriptive. Also keep in mind that this happens to also be a LeetCode problem, LeetCode 160, where we're given two lists, A and B, where A is A1, A2, C1, C2, C3, and B is B1, B2, B3, C1, C2, C3. Then we have to return the intersection of these two lists, which obviously is starting from C1 to C2 to C3. So without further ado, let's go ahead and solve this problem. But first, today's motivation is from Colin Powell, and I quote, "There's no secret to success. It's the result of preparation, hard work, and learning from failure." Hey guys, as you keep going forward, learning new things and chasing your dream, you're gonna encounter so much failure. However, if you keep learning from your failure, keep staying prepared, keep working hard, keep moving forward, you are gonna get to that destination that we call success. Keep in mind, success is always more about the journey than it is about the actual destination. So we're given a linked list here, L1 and L2, okay, which is the head of both linked lists. From this visual, you can see that both linked lists intersect at 4 and 5. You want to return this intersection, and keep in mind, the first hint says not to use a hash table, but today we are gonna use a hash table because I think that's the simpler method, but we're also gonna have a follow-up video where we actually solve it the most efficient way. So first, I'm gonna define a function, intersection node, and this function is gonna take in the head of both linked lists, so in this case L1 and L2. And the first thing I want to do is create my hash set. So I'm going to call him node set, and I'm going to set him equal to an empty hash set for now. So essentially what I just did was I just created this empty set that we're going to add some values to, and you're going to see how in a second. So next, I'm also going to create a pointer called current pointer. Current is going to be equal to L1. So right now he currently points to L1. So this is where current currently is. And the aim is we want to iterate through our first list. And as we iterate through, we want to add every single value in him into our hash set we just created. Here's how we do. We do that with a while loop. While current is not none, we're going to go ahead and add it. So for each set, we're going to add to our node set. So node set dot add. And what do we want to add? We want to add current. Keep in mind, we're adding current the node, not the value, not current the value. We're actually adding the node. And then once we add it, we're going to increment cur, just moving him to the next guy. So cur is going to be equal to cur.next, and that's it for this while loop. So let's go ahead and actually perform what this while loop is going to do. So in the first instance, cur is on node 1, so we're going to go ahead and add him to our set. Keep in mind, we're adding the node, not the value. So technically, since it's a linked list, if we add just the node, we technically add everyone else because each node has two properties, the value and the next pointer. So now we've added the first value, then we're going to move current forward. So cur now moves to cur.next, and then we're back at the top of this while loop. We do the exact same thing. Now we're at node 2, we're going to add node 2. Like I said, linked list contains the value and the next pointer. Since we're adding the node, not the value, we essentially add everyone else. So we're going to add 2, 3, then we're going to move current to current.next. But at this point, I think you can see the theme, right? We're going to add everyone in L1, and then this is what the final result when we're done iterating is going to look like. At this point, current is going to be somewhere out here, pointing to none. So we're going to add 5, and we're going to terminate our list, obviously, because there's nobody else to add. So technically, you could choose to write a none right here. So now we're done with the list L1, and we're done appending him to our hash set. We can go ahead and close our hash set. So next, we're going to have to go through L2 and check each value in L2 if he exists in this hash set. And here's how we do it. We're going to first start by reinitializing our current variable to the head of our second list, which is L2. And then with a while loop, current is now pointing to the head of our L2 list. So with a while loop, we're going to iterate through L2. So while current, first thing we're going to do is we're going to check, does the current value I'm on, the current node I'm on, not value, does current, is he already in my set? If the answer is yes, we're just going to return current, because that's the whole purpose of this example, to find the intersection of the lists. But however, if the answer is no, we're just going to move our current node forward so we can iterate through the rest of the list. Then at the end, once we're done, once we've reached the end of the while loop and the loop breaks, we're just going to return none, meaning there is no intersection between those two lists. So this is pretty much the complete code, but let's go ahead and show what it looks like. So first, current is going to be here, pointing to 2. So we're going to check our set. It's the node 2 here. technically, I know you might look at this second item in the set and say, yes, the node 2 is there, but no, keep in mind that this 2 right here current is pointing to, his next pointer points to 4. However, this 2 right here in our set, his next pointer points to 3. So these two tools are completely different. So we're gonna go out here and move current forward. So current moves to current.next. And then at this point, we're gonna check 4. Is 4 in our hash set? Yes, 4 is right here, right? They are the exact same because this 4 here, current is pointing to, his next pointer points to 5 and then points to none. Same here, this 4's next pointer points to 5 and then points to none. So we are just gonna return this item right here, which is going to return 4. Let's go ahead and see what this looks like on our code editor. I've gone ahead and created the node class, which is the building block of our linked list, created our linked list class, created our append function. Again, this function is not too useful here because this is how you append values to the linked list. I created the second append function called append node, which is how you append actual nodes. When given a node, you append it to the linked list. Created the display function so we can visualize and see our linked list. And now this is the actual function we just wrote on the whiteboard. I'm just printing him so we can see it. And then first I create my intersection. Again, in this case, in the example we just saw, our intersection is just 4, 5. So which is what I do. I create 4, 5. I added an extra 6 just cause. Then I create my first linked list, which is linked 1, linked 2, 3, and then I append the intersection head node, which is 4, which technically appends the rest of the intersection to him. So that's how we have 1, 2, 3, 4, 5. I do the same thing with list 2. I create list 2, which starts with 2, and then the next I append a node, the head of my intersection list, which is 4. So that is also how we have 2, 4, 5, pointing to the exact same intersection. And then I display both linked lists, link 1 and link 2, which is right here, and then I call my function, and then it returns correctly the intersection. Let's change the intersection numbers just to make sure it's the same. So here I'm going to put a 99, here I'm going to put on a 96, and here I'm going to put in the string, let's do something stupid, let's put in the string A. Okay, let's go ahead and run it. Again, we still return the intersection correctly. Let's also go to a LeetCode. This is the same LeetCode problem. Let's go ahead and submit it and see how we do. Boom, we're 90% fast. So that's it for the video, guys. I hope it was helpful, and I'll see you in the next one where we actually solve it the right way without using a hash set.